Today we're going to talk about the fundamental theorem of calculus. There are two parts to this. We're going to talk about the first part today. Then we're also going to dig a little bit more into definite integrals. Okay, the first fundamental theorem of calculus. Just like many things in calculus, if f of x is continuous on the closed interval ab and differentiable on the open interval ab, then the first part of the fundamental theorem of calculus says the derivative of the integral from some constant to x of f of t dt equals f of x. Okay, essentially the integral and the derivative are inverses, if you think about it like that. They undo each other. So if I take the derivative of an integral, we get f of x. There are a few special cases that we want to talk about also. This is primarily what we're going to do, but sometimes you'll go from a constant to a function. So we have to apply the chain rule. So it is just going to be f of x, but it's going to be f of g of x times the derivative of g. The chain rule still applies. Similarly, if both of these are functions, and this is going to relate to the second part of the fundamental theorem, which we haven't really gotten to, but we're going to have f of the top one times the derivative of the inside minus the derivative of the bottom one. Okay, and this will make more sense later, but it's going to be the function evaluated at h of x times the derivative of h of x minus the function evaluated at the bottom times g of x. So let's look at some examples. Okay, this really will almost seem too easy to be true. If I'm taking the derivative of an integral, this is just going to be x cosine of x. Essentially, take the x and plug it in for the t. That's it. This will be 1 over 1 plus root x. Okay, these next ones have the function involved. So a constant to a function. We're going to take this, and instead of t is going to be x cubed. Sorry, x cubed times the derivative of x cubed, which is 3x squared. Here I'm going to take this x squared and plug it into both of these. So this will be x squared minus 3 over x squared squared plus 7 times the derivative of x squared. Okay, here it's going to be the top minus the bottom. So this will be cosine x cubed times 3x squared minus cosine x squared 2x. This one's going to be 3 over x plus 1 minus the bottom, so 3 over negative x plus 1 times the derivative of negative x, which is negative 1. So now we're going to talk about some properties of definite integrals, and most of these are going to seem fairly straightforward. Okay, the first one, the integral from a to b of a constant k times f of x. We can pull that constant out, k times the integral of the function. The second one, the integral from a to b of the sum of f of x plus g of x, we can rewrite it as separate integrals. So the integral from a to b of f of x plus the integral from a to b of g of x. The next one, if we have the integral from a to b of f of x, that's going to equal the opposite of the integral from b to a. So if the bounds are flipped, then it's going to be the opposite of whatever that was. Okay, the next one, if a is less than b is less than c, then the integral from a to c of f of x is equal to the integral from a to b of f of x plus b to c. So looking at this graphically, the integral from a to c is all of this. Well, I can break that up into this area plus this area. So that's all that's saying, is the integral from a to c equals the integral from a to b plus b to c. The last one is the integral from a to a of f of x equals 0. Okay, so going back to my graph, if we are going from a to a, then we have no width, so there is no area. So that's always going to be 0. Okay, these ones, the integral is just adding the areas. If area is below the x-axis, then that area is considered negative. So this would be a1 minus a2 plus a3. This one we have some numbers, so pay attention to our bounds. We're going from a to c. So that's going to be 1.8 minus 2.3, which is negative 0.5. If I go all the way from a to d, that's going to be 1.8 minus 2.3 plus 1.4, which is 0.9. Okay, so now we're going to use these properties. We have these three rules, or definitions, I guess. So for f of x from negative 1 to 0 is 3. The integral from negative 1 to 2 of f of x is negative 1. And then the integral from negative 1 to 2 of g of x is 2. So we're going to find different values based on that. So the integral from negative 1 to 0 of 8 f of x, well, if from 0 to 1 of f of x is 3, then this will be 8 times 3, which is 24. The integral from negative 1 to 2 of f of y. Well, it doesn't matter what the variable is. If this is 3, this will be 3. Okay, the integral from 2 to 2, 0, always. Okay, the integral from 0 to 2 of f of x. Well, I have information about from negative 1 to 0, and I have information from negative 1 to 2. So to get from 0 to 2, I'm going to take this and subtract this. So this is going to be the integral from negative 1 to 2 of f of x minus the integral from negative 1 to 0, because we'll just take off that piece. So that's going to be negative 1 minus 3, so negative 4. Okay, the integral from 2 to negative 1 of g of x. Well, negative 1 to 2 is 2, so 2 to negative 1 is going to be negative 2. Here we're combining, the bounds are from negative 1 to 2 of f of x minus 2g of x. So f of x from negative 1 to 2 is negative 1. G of x is 2, so this ends up being negative 5. Okay, this last one, I can split this up into 3 times the integral from negative 1 to 2 of f of x minus the integral from negative 1 to 2 of 5. Well, this one's just going to be 3 times our negative 1. This one, if I just had a horizontal line at 5, from negative 1 to 2, the area would be 5 times 3. So this would be negative 3 minus 15, which is negative 18. All right, so now we're getting fancy. We've got a limit with an integral. So first I'm going to look at what happens as I plug in 1 into the top and the bottom. Well, if we plug in 1 for x, that's going to be the integral from 1 to 1 of cosine of t, which is going to be 0. The limit as x goes to 1 of the bottom is going to be 1 squared minus 1, which is also 0, which means we have L'Hopital's rule. So now we're going to take the derivative of the top which is the first fundamental rule, which is going to be just cosine of x, over the bottom, which is 2x, and then we'll plug in 1. So that'll be cosine of 1 over 2, which is as far as we can go there. All right, so capital F of x is the integral from 0 to x of cosine of t over t squared plus 3. So f of 0 is going to be the integral from 0 to 0, which is just 0. Okay, f prime of x is going to be the derivative of this integral. So that's going to be cosine of x over x squared plus 3. So f prime of 0 is going to be cosine of 0 over 0 squared plus 3, which would be 1/3. Okay, the second derivative is going to be the derivative of this. And we have a quotient. So it's going to be the derivative of cosine of x good old quotient rule all over the denominator squared. Okay, so this is going to be negative sine of x times x squared plus 3 minus 2x cosine x over x squared plus 3 squared. So f double prime of 0, sine of 0 is just 0, so that whole piece is going to be 0. And then 2 times 0 is 0 over 9. Which is just 0. So that is the first part of the fundamental theorem of calculus and some properties that we can use.